2008, the National Academy of Engineering released a list of 14 21st century issues that, if solvable, would likely provide great societal benefits. Today we're going to be talking about one of those challenges, the restoration and improvement of urban infrastructure. Over the next few slides, we'll identify and define the core aspects of the challenge, investigate the root causes that created the problem, and finally look into possible solutions from an engineering perspective.
Our main goal for this challenge is to improve the structures such as buildings, highways, and bridges. Our primary reasoning for this is due to the lack of preparation these different systems have regarding their readiness for natural disasters. Among these natural disasters, earthquakes are our main concern. Earthquakes pose serious threats that could happen anywhere in the world at any time. Floods, hurricanes, blizzards, and tornadoes, some of the most expensive natural disasters, are not only limited to certain regions, but we can also know when to be ready for them. Earthquakes, on the other hand, are spontaneous and although more likely to happen in certain locations than others, are also more likely to strike anywhere in the world than these other natural disasters. The United States has an annual loss of about $4.4 billion just from earthquakes. The cost of the damage can vary quite drastically, such as the earthquake that hit Japan in 2011, which costed about $232 billion. Although we may not be able to avoid all the expenses these natural disasters bring, upgrading our structures and equipping them to be better prepared for whatever disaster may come will only cut the expense quite dramatically.
With each passing year, winter, fall, spring, and summer, the infrastructure slowly deteriorates. With each storm and rainfall, blizzard and hurricane, it takes a toll on the roads, bridges, sidewalks, lights, and even sewage systems. A prime example of this would be the roads and highways that wind through the Rocky Mountains. Each winter, water sinks into the cracks and divots in the road, and once the temperature drops below freezing and it begins to snow, the water that was once in the roads now freezes and expands, therefore cracking the pavement. Once it begins to warm up, workers will have to seal these cracks in the roads to prevent further damage. Nature is the biggest thing that is tearing down the infrastructure aside from humans themselves. People drive all year with their studded winter tires, thus tearing the roads up.
Improve our infrastructure, we look to engineering for the answer. Here, we look at three big areas within our infrastructure: reduction of energy waste, groundwater management, and protection against climate change. In order to cut back on energy waste, we can install solar panels throughout the city, then switching over to electricity at night to cut back on energy waste. Next, we look at groundwater management. We capture the rainwater through a series of pipes that lead to a filtration system, filter all the minerals out of the water, and transfer the remains to an aquifer storage system. Finally, we turn to protecting slum-condition areas along the coastline against severe weather events. To sustain against these conditions, we can create higher elevated and thicker structured buildings and roads to ensure the safety of citizens.
Wrapping up, I just want to talk briefly about infrastructure as a whole. The National Academy of Engineering defines infrastructure as the combination of fundamental systems that support a community, region, or country. So with that broad definition in mind, we should make sure that we're not just focusing our efforts on completing a single project. To be really successful, we need to focus our efforts on continual improvement and investments into future projects, not just stopgap measures that address today's problems.